the section's on 5.4 properties of logarithmic functions. So there are three specific properties that we need to go over. One of the properties is the product property. So the product property says that if you condense it, and I call it condensing because you're making it smaller. So to condense it, you have as log base A, and then you have as m times n. So this is the condensing part of it. If you need to expand it, then the m and the n will be separated by an addition problem right there. You still need to put the base right there for each one of those. So whatever this base number is right here, that's what's going to be the basis for that part right there. Okay. The other one is the quotient. So the quotient is the division. So again, the condensing part of it is the division sign right there. And to expand it, then you're going to have to separate the division with a minus. So I usually remember is the division sign right there. That's like a big minus sign. So that's going to be the minus right there. Okay. So the m, and so whatever's on the top would always be the first part. And then it's minus, and then the n part right there. Okay. So again, that's still the same base right there. And then this is the power rule. So the power is kind of what we use for the property on the last section when I talked about changing bases. So when you have an exponent on top of this m right here, the property says that you can expand it by putting this p all the way up to the front, and it becomes p instead. And so it's a big P right here. Then log, again, same base right there, m, and then you just don't have a power. So condensing it now to go this direction is this part right here. You just want to make it smaller. So to make it smaller, you would pull the p back here and make it look like this. To make it smaller, you would go from minus and turn it into a division sign. And then for a plus, you would turn it into a multiplication sign right there. Okay? So those are the three main properties for this section right here. So now using those properties, we're going to either expand it or condense it and figure out what the rest of the problem is. So the problem on this one is asking us to take the log base 3, and then it says 9 times 27. So we're going to go ahead and solve for this. So we need to go ahead and expand it. So to expand it, we have is log base 3. So multiplication turns into a plus, right? So it's going to be 9 plus the log base 3 of 27. So now this becomes similar to what we just did on the last section. We're solving for it. So we're solving for is just this piece right here. We're trying to figure out that pieces. We're trying to figure out this pieces, and we're going to add them together. So in order to solve for log, and let me just do this on the side, it's like log base 3, 9 is equal to, and whenever you're solving for something, you put an x right there. So this needs to be an exponential form to solve. So if I bring all of this over to the other side, we then have is 9 equals 3 to the x power. And then to solve for x, it's going to be 3 times something to the power of becomes 9. So x is equal to 2, right? Because 3 times 3 is 9, so it has to be a second power. And then doing the same thing with this one right here, it's going to be then log base 3, 27 is equal to x. So if I bring the base 3 over to the other side, it becomes 27, 3x. So then 3 to the something power has to give us 27, so it's probably 3, because it's 3 times 3 times 3 is 27. So x equals 3. So now this is right here, x equals 3 represents this part, x equals 2 represents this part right here. So if we add them together, it becomes final answer is equal to 5. So this whole thing is equal to 5 is the correct answer. Okay, so we're going to do the same thing for this one. We're going to try to expand it out. Now in this case, if we have letters, we don't have to worry about solving for it, but if you have numbers like this previous problem right here, you do need to solve for this out. So on this one right here, we're just going to go ahead and expand it. So this expansion right here is multiplication right here. So then I have is log base 3 p to the third plus, right? And then we have is log base 2. Oops, then that should be 2 right there. So log base 2. And then q. Now, whenever you're doing these kind of problems, make sure you have expanded as much as possible, because when we have something like this, the power, it says back here that I can do the power rule. The power rule says that if I have an exponent up here, I can always pull it up to the front. So that's what you're going to do with this 3 right here. You're going to pull it up to the front right here. So you're going to have is then 3 log base 2 p plus log base 2 q. And that's your final answer for the expansion part right there. Okay? Let's try the next one. So we have is log base t 8 divided by w. So when we have a division and we're expanding it, division, remember, turns into a minus right there. So we're going to go ahead and do that. So we have is log base t 8 minus, because remember this is like a big minus sign right here, minus log base t, and then we have is w. So then from here, is this the most simplified form? Not really, because 8 can even be smaller than that, right? Because then couldn't we do like 2 to the third powers to give us 8, right? Because this 2 times 2 times 2 gives us 8 right there. So that can be reduced to a further. And since this is power, then we have to bring it up to the front. And then we have is 3 log base t 2 minus log base t w. So we always look for something that is the most simplified form. It's almost like factoring. You want to take out as much as possible with the same idea with this one. You want to do as much as possible to make it smallest or an expanded form right there. Okay, let's try the next one. Now, we have some combinations when you do these kind of problems. So when you have a combinations, it's almost like you have to take little steps at a time. So to take a little step, what you're going to do is you're going to do this part right here. We're going to leave that right there. We're going to go ahead and do a minus right there, and then we're going to separate this. So what does that look like? We're going to keep that log base, well, that's a base 10, right? Because there's nothing there. So we'll keep this x to the second power, y to the fifth power up here. We'll keep that together right there because it's a parentheses right there. Now let's separate this right here. We have as log base 10 z to the 4. Now let's go ahead and separate them. So now I can separate as this part right here. So then we have as log base 10 x to the second power. And then it's multiplication right there. So we're going to go ahead and plus log base 10 y to the fifth. And then we just copy this piece right here. Log base 10 z to the 4. Okay? And again, we're looking for as much as possible the simplified form. So we have bases or powers on each one of these guys right here. So we can pull it up to the front. So we should have is then 2 log base 10x, right? Plus, and then we bring the 5 up to the front. 5 log base 10y minus, and then we bring the 4 to the front. 4 log base 10 z, and then that will be your final form of expansion. So the expansion actually should look at what it says. It should be expanding. If it's not expanding, then something went wrong. So go back and check that piece right there. Okay? All right, let's try another one. So the next one right here. So what we're trying to do is, again, we're trying to expand it as much as possible on this one right here. So to expand it, we're going to have to change this exponent right here, the third root, into a exponent. So let's go ahead and do log, and then I'm going to go ahead and a squared b all over c to the fifth, and then to the 1/3, right? Because 1/3 will give us then that piece right there. Okay? Now, this is number or the power of it, so we need to change that. So bring the power up to the front. So then we have is 1/3, and then we're going to go ahead and put parentheses, log, and I have then is a squared b, so a squared b divided by c to the fifth, c to the fifth. Okay? All right, so that was the first step by just bringing this to the front right there. So now we have to go ahead and try to make it smaller or expand it as much as possible. So then again, the 1/3 is still here. Then I have as log, and we have then is a to the fifth, or I'm sorry, a squared. So a squared b. I think we can go ahead and separate this right here, like the last problem, right? So let's separate right here. So log, and then go c to the fifth right here. So I'm going to go ahead and leave this in parentheses right there. So now we're going to go ahead and expand this piece right here. So I have a still 1/3 log a squared, and then plus, right? Log b minus log c to the fifth. Now I can go ahead and move the powers to the front. So let's do that. So notice that the 1/3 is out here, and it's parentheses for all of them because technically this 1/3 belongs to all of this right here. So if you don't do the parentheses, you're not going to get the correct answer. So make sure you put a parentheses around all of that right there. So let's bring the 2 in the front. So we have is 2 log A plus log B minus 5 log C. Okay, is there anything else I can do? I think I can go ahead now and distribute this 1/3. So it's not wrong if you actually leave this 1/3 out. It just depends, I guess, the problem. If you have to put it into the computer, or if it's a multiple choice, then most likely they're going to go ahead and distribute that. So they'll distribute this 1/3 to here, giving you 2/3 instead. So we'll have his log. And then once you distribute, remember the property of distribution is to get rid of parentheses. So it's 1/3 times this piece, so which is then just regular 1/3, because it's like a 1 right here. So it's 1/3 times that 1, log B, and then minus 5/3, and then log C. And that's about it. So this is going to be your final answer right here. Okay, so that's the most expanded form. So you may want to go back and check that one again. The next one we have then is to go backwards, is to condense it. So we're going to make it smaller. So to condense them, we're going to go ahead and bring the powers back. So I would always do the powers first. So it's like going the opposite direction, right? So we want to bring the powers in. So then we should have is log base B x to the 5th, and then minus, and I just copied this piece right here because we haven't done anything with that one, plus log base B z to the 1/4. Okay, so now once we get here, we want to do little steps at a time. So we want to go with these first two right there, those steps right there. So since it's minus, to condense it, it's going to be a division sign, right? So x to the 5th divided by, and then y plus, and then we still have is log base B z to the 1/4. So now plus turns into multiplication. So then we multiply these guys together. So it becomes the multiplication of x to the 5th times, right, z to the 1/4 all over y right there. Okay, now again, this could be the final form right there, but sometimes they'll take this 1/4 right there and they'll simplify it further, put it into a radical. So if you put it into a radical, it'd be log base B x to the 5th, and then you would do the radical right here. So 1/4, right, because that'll be 4z all over y right there. So that will be your final answer right there. Okay. All right, and then we have is this one. So the last part they do is they give you something, it's almost like the key. So they'll say log base A 2 is equal to 0.301. Log base A 3 is equal to 0.477. And they'll give you a problem like this. Well, they'll say log base A 6. So somehow I need to go ahead and use the 3 properties to then go back and substitute these pieces together. So, for example, like I can go log base A and then 3 times 2, right? Because 3 times 2 is 6. So now I can expand that right there. So log base A 3 plus log base A 2. So now this becomes exactly this right here. So that's the 0.477. And then this right here becomes exactly that over there. So if we add that to 0.301, so the final answer then becomes 0.778, right? So that will be your final answer right there, okay? So you'll have some of those kind of problems. And then the last problem is something like this, where you have a division sign right there. So again, the only thing I'm trying to make it into is either 2 or 3 because I need to somehow substitute that in. So can we see then 4 is the same thing as 2 to the 2nd power? Because then that gives us then the 2 that we need. So it becomes something like this, right? Because if it's 2 to the 2nd power, then that's going to give us this part right here. I can always go back and change. So now let's go ahead and separate that. So expand it. So we have then as log base A1 minus, right? Log base A 2 to the 2nd power. So then this 2 can come up to the front right there. So we have as 2 log base A2. So this looks good. Now this part is not part of the key over here. So we may have to do some solving right here on the side. So if you have log base A1 is equal to x right there, and I want to change this into exponential form, so I change it to exponential form, I then have is something like this, right? because a comes over, becomes base a right here, x gets pushed up. So you're trying to figure out is a to the something power gives you 1. What is something that is always to that power of will give us 1, right? 0, right? So a to the 0 power gives us 1. So in this case, this actually all turns into a 0 right there. So it's 0 minus, and then this piece right here, I can substitute it in with this piece right here. So then it becomes 2 times 0.301. And if I multiply those together, it becomes negative, what, 0.602 as my final answer right there. Okay? So those are the types of problems that you'll be doing, as you'll do some of this kind of problem, you'll do some of this piece right here where it's expanded and then you want to condense it, and then the vice versa where it's condensed and then you want to expand it as much as possible.